Hello everyone, how are you all? Hope you all are fine. So welcome to that the part 2 for the simple linear regressions. So in that previous video, so we'll just discuss all about till cost function. So you already know. So why the cost function name came in this concept, because uh, it will help to minimize the error, right? So I just let me just revise it. Okay, so let directly start from that concept. Okay, so after that we'll talk. So here, what is cost function? So if you don't know, or let me just revise this one. So cost function is like what? So 1 by n, then summation of I equal to 1 to till n, means n number of data. Okay, then yi, then h theta of x whole square. Clear? So this one is what? Yes, this one is what? This one is this one is the MSE. So MSE stands for mean squared error. So this is the mean square error, right? So now, so here, so let's start what is that hypothesis line and what is that cost functions. Okay, so with the help of the cost functions, so first of all, with the help of that linear line formula, we will just draw one hypothesis line, because our aim is what? We have to just create a best fit line. Okay, so which will be give the minimal error, right? So now let us start. Because listen, so in this video, so we will just get to know like many concepts from this from this cost functions and the hypothesis. Another new name you will just get, so that is very important. So please just listen carefully. So for example, I'm just drawing one graph. This is one graph, and this graph is having like a let theta is equal to, so your formula is what I explained. H theta of x is equal to theta 0 plus theta 1 x1. All right. So here, so let's assume that I'm just taking that theta 0 is equal to 0. So whenever theta 0 equal to 0, so in first case of theta 1 is equal to 1. So let me just put, so here 0 is means total put is the 0. So now just tell me, so whenever x equal to 1, x equal to 2, x equal to 3, so here this part is the x-axis, this is the 1 and this is the 2 and this is the 3, right? And this is the 1 and this is the 2 and this is the 3, right? So now whenever x, so this is the formula. Okay, this is the theta 1 and x1. So this is the formula. It means what? So 1 multiplied 1 is equal to 1. Similarly, 1 multiplied 2, because at the place of x, so I'm just inserting that 2, which is the 2. Similarly, 1 multiplied 3, which is equal to 3. It means what? So it will be generated 1, then 2, then 3. Clear? So then the line will be drawn as it is. How? So here it will be drawn like this. Clear? Clear? Very good. So now, so this is the case of what? This is the case of that theta 1. So whenever if theta equal to 0.5, then what will be happen? If theta value will be 0.5, then what will happen? So now it will be like this one, like a 0.5 multiplied 1 for the one case. What? 0.5. Similarly, 0.5 multiplied 2 equal to 1. Similarly, 0.5 multiplied 3 equal to 1.5. So hence, the means like 0. So in the case of 0.5, 0.5 is where? Yes, 0.5 is where? So in the case of the 1, 0.5. In the case of the 1, x equal to 1, this one is the 0.5. Similarly, in the case of D2, this one is the 1. This one is the 1. And in case of 3, this one is the 1.5. Okay, this one is the 1.5, right? So if I want to draw one line, now the line will be generated like this. Okay, the line will be generated like this. Clear, everyone? So now here, so first of all, we'll calculate this one, the distance between this, the distance between this, and distance between this. Then after that, we will calculate what? So after that, we'll calculate the distance between these two, then this line, then this line. Okay. So likewise, we have to calculate. So now here, it will be helped like how I will reduce the what our goal is what to minimize the error. Okay, our goal is what to minimize the error. So let calculate the error. Let calculate the error. Okay, so let calculate the error. So whenever j is equal to theta 0 and theta 1, which is equal to 1 by 2n, then sum of 1 is equal to 1 till n is equal to what? I, yi, then h theta of x of I equal to square. Okay, so this is the formula. Okay, of whom? This is the formula of the cost functions. Okay, so right now let me put what the value. Okay, so how to just put it? Listen. So here y theta is there. Okay, so y theta is there. So now in the linear regression part, so how to solve it? Yes, how to solve it? So here, so whenever just will like trying to solve this one, so it will come like a what solution? So here 1 by 3, the output will become. So try to just solve, because here the previous value you have to take. Here the previous value you have to take, right? Previous value you have to take. So 1 negative 1 square, right? Then plus, okay, for x and for y case. Then for x2, then 2, okay. Then because 1 1, our data set is 1 1 1 na, so 3 and 3 6, okay. Then similarly, then we are getting what? We are getting j theta 1, okay. So here equal to 0, because our data set is what? Our data set is 1 1 2 2 3 3. So in the previous part we are getting here this line, okay. Now next point. So now, so first point is the 0, okay. First one is the 0. For similarly, so let's go for the second line. Okay, so here we are just calculating this part. Okay, so here first of all we are calculating this part. Okay, then let's calculate this part. Okay, so now next, how to just calculate? Similarly, j theta 0 theta 1 is equal to, okay, so let me use another color. So 1 by 3, 1 minus 0 0.5 whole square plus 2 minus 1 whole square plus 3 minus 1.5 whole square, right? So now the answer will be what? So I already just solved this one. So please just try to solve this one, and your answer will become near to this one. Clear? Right? So similarly, if I will write that theta 1 equal to 0, if any case, if I will just write theta 1 is equal to 0, because my aim is to come here only, okay. Theta 1 equal to 0, then what will be happen? So 0 multiplied 1 equal to 0, 0 multiplied 2 equal to 0, 0 multiplied 3 equal to 0, hence total is the 0. Yes or no? Hence total is the 0. So that's why j of theta 0 theta 1 is equal to what? Theta 1 is equal to, let me use another color. So here 1 by 3, then 1 minus 0 whole square plus 2 minus 0 whole square plus 3 minus 0 whole square, then what? So if we'll just solve this one, so you'll get 4.66. Okay, so it means what? So it is what? Increasing. right? So now, so how to listen, how to manage this cost function, how to manage this cost function. So how I will just get that how I will just get that value means like for example, let me just draw the graph. First of all, let me just draw the graph. So this is the graph first of all. So if this is the graph, so first of all, what I get, yes, first of all, what I get, so I get the zero part. So in the zero part, okay, in the zero part, I'm just getting, okay. Similarly, so this is the zero. Okay, so theta, whenever theta 0 equal to 0, okay, so this one is a what? So theta 1 is also a 0. Okay, so now next point is what? Next point is what? Whenever theta 1 equal to theta 1 equal to 0 0.5, then I'm getting what? J value. So this is the j theta. Okay, j theta 1. Okay, and this is the theta 1. Okay, so think that. So if this one the 0 0, first point is coming. Okay, and second point is what? Yes, second point is what? So 1.6. Similarly, 1.6 whenever it is equal to like this. Similarly, so if I will just get this one, so then the value will be move on like this. Okay, it means what? Listen, point is what? Listen, I'm just explaining again I'm just explaining because maybe it will be create one doubt. Listen, first of all, listen. So I'm getting some j value, right? I'm getting some j value. So here in this j value, so we are calculating what? So we are just calculating what? So first of all, with the help of the that hypothesis, I'm just calculating what? So here these are the theta 1 case, these are the 0 1 and 0 0.5 cases. So accordingly I just solve this cost function. So after the solving this cost function, so how I just get these values. Okay, so now my aim is what? My aim is what? To like a change in between whenever listening. So in this graph, so what you just find, so here whenever theta value will be changed, then the theta 0 will be changed, then theta 1 will be it will be slightly, it will be what changed. When theta 1 will be changed, then automatically theta 0 will be changed. It means what? So first of all, our aim is what? Our aim is like to maintain or to minimize the error, right? Are you getting? To minimize the error, our aim is to minimize the error. So here another concept is coming, means like one algorithm is coming, right? One algorithm is coming and he's saying that, okay, so don't worry, I'm here, I will just minimize, I will help you to minimize the error, I will just help you to minimize the error, right? So here, so how? So listen, this middle part is what? This middle part is what? Yes, this line is what? This line is nothing but the slope, right? Yes or no? So how this slope is created? How this slope is created? So listen, first of all, there is a one method, the method name is what? The method name is the convergence algorithm. Convergence algorithm. What is the convergence algorithm will be do? So here, this one is the one type of what? This one is the one type of optimizer. This is the one type of optimizer. So what will be optimizer do? So here, the change of theta, the change of theta 0 and theta 1 to global minima, It means what? Why we are just doing this? These are things. So here theta 0 and theta 1, theta 0 and theta 1, theta 0 and theta 1. It's what? So it will be changing. Because of what? Because of to minimize the error. So here this convergence method will be do what? So it will be repeat until whenever we are just not reach out to that what? The global minimum. Remember the name called the global minimum. Okay, so the algorithm is what? Theta j is equal to theta j of negative alpha. This one is the alpha. Then derivative of j of theta j and divided by derivative of theta j. So here, listen. So here, this part, this derivation part is nothing but what? So it is deriving what? So it is derive this slope. Derive this slope. It means what? So in this derivation only we are creating the slope. Clear? We are creating the slope. So it means what? It means what? So whenever let us assume that I'm just drawing one graph, so this is the graph. Is it visible? Yes. So this is the graph. So whenever the theta value will be changed, whenever the theta value will be changed, so sometimes the theta, if the theta 1 equal to this point 1, then the theta value will be like what? 1. When theta value equal to like 0, okay, 0, so then it will be like what? So it will do like this. The time will become whenever theta value will be changed, theta 1 value will be then theta 2 value will be changed. Okay, similarly like it will do. So it will be create the U type of structure. The U type of structure. Because of whom? Because of the changes of that theta 1 and theta 2. So here, this concept is nothing but known as what? Gradient descent. Gradient descent. So what is gradient descent? Gradient descent is nothing but what? To minimize the error. So here, this part is nothing but what? Derivation part. It is creating the slope part. So what is the slope part? How it is creating? So if you will just, if any data point will be here. So if I'll draw one graph, if I'll draw one slope. So this slope is nothing but what? Negative slope. And if any data point will be here, and if I'll draw the slope, so it will be what? Positive slope. So our aim is what? To minimize the error. To minimize the error. The data set will become here. Okay. Till what? Till here. So how it will become? Okay. So if we'll just take big steps, then it will be never come here. So you need to take that small step. If you take small steps, then it will become. If you take big step, okay. If you take big step, the step will be like this. The step will be like this. So this step, the step value is indicating, this step value is what? This step value is nothing but the learning rate. So it means what? You have to focus on the alpha value. So alpha is nothing but what? Learning rate. Clear, everyone? So whenever you are doing the program and you are just what? You are just like focusing on the alpha value. So if alpha value, so in that time, so alpha value will be 0.01. So it will be like very small. So if we take this one, then we will never reach out to the global minima. So why our aim is to reach out the global minima? Because we have to minimize the error. So here, let me just these are the concept. Okay, only this much is there. Okay, there is not another anything, no concept. Okay, it means what? So let me just revise again. So in this simple linear regression, so what type of concept we just get? So here we get first of all in simple linear regression, so we have to, our aim is what? To create the best fit line. Okay, so whenever just we are moving to best fit line, so here what will be happen? So here one linear regression problem means one linear formula is coming, right? One linear formula is coming. So here this linear formula, this linear formula will be help us. Okay, so this linear formula will be help us to create the best fit line. So whenever just we are creating best fit line, so there is a maximum error part is coming. Okay, maximum problem is coming. So we have to solve that problem. So now there is a hypothesis line. That slope value is nothing but the hypothesis value. So now coming to hypothesis value, so there is a maximum problem is coming, like error part is coming. So a overfitting problem, if there is a overfitting problem, okay, many problem is there. Okay, but so here in that, while solving that error, so we are just moving towards the cost function. So in that cost function, so we are just calculating the error value, and error how it will be solved. So while changing the theta 0 and theta 1. So while solving this problem, error problem, so one means like how it will be changed the theta 1 and theta 0 part, because continuously if it will be changed, maybe chances is there, maybe chances will be there. Do you know what is the theta 0? So this part is nothing but the theta 1, and this part is nothing but the theta 0. It is continuously changing, okay, till it will be not reach out to the what? Global minima. So this part is nothing but the global minima. This part is nothing but the global minima. Which part? This middle part. Clear everyone? Clear everyone? Okay. So this part is nothing but the global minima. So hence these are the concepts. So hence you have to know what is the convergence rule. And listen one thing. So if this structure, the gradient descent will be, if the gradient descent will be like this, if the gradient descent will be like U structure, so this concept is nothing but the convex, okay, convex convergence. Okay, so if any will become, so in this convex convergence, so the global minima will be there. But according to the concave, if you are moving towards the concave part, so the concave part will be like this. So here is the global minima, this one is the global minima, but these are the what? Local minima. These are the local minima. Okay, here there is a problem. This one is the concave part. Clear everyone? So these are the concepts. So I think, hope you clear the concept. So that's it. Okay, so we'll move to the next. So I will just try to practically implement all this algorithm. Okay, so don't worry. So that's it. So if you'll just like the video, so please do like and subscribe and share it to your friends. Okay, so that's it. Bye. Thank you. Okay, so now let me